Welcome to week 5, everyone. Thank you for your understanding this week in terms of the change in schedule due to our losing our guest speaker. Today's lecture is going to be on Oracle, basically to give you overall a high-level perspective of what a enterprise database management system consists of. There's a number of terms that we're going to be going over today that are going to pop up over the next couple of weeks. And we're going to be doing a deeper dive later this semester in terms of actually how to build a database using Oracle. Related to logistics for class in terms of housekeeping items, there's going to be this lecture that's posted today that you'll need to view, and today's quiz will be 6 points versus the usual 3. The first 3 points being from the lecture from last Thursday and the items that have been posted on Moodle, and then other questions that are basically identified in the lecture that we're about to begin. So without further ado, I'm going to switch over to the PowerPoint deck and start to walk you through the lecture. So enjoy. So when I talk about introduction to Oracle, I want you to think of it in two ways, and we're essentially physical and logical. And I'm going to walk you through both the physical structure and the logical structure, and really what that encompasses according to how Oracle maps itself out. As you know, I'm very fond of definitions, and these definitions you're going to really just need to understand throughout the semester as it relates to Oracle. You've seen some file names and file extensions related to access, and understanding these file extensions will help you as we get deeper into the Oracle portion of the semester. I always start off with data files because it's a concept that you're unfamiliar with related to access. Within Oracle, from a physical perspective, data files really contain all of the database data. So all of the information that you're actually physically storing is what's part of the data files. When I get into the control files gets into really what acts as the skeletal framework for the system. It will identify essentially the physical structure, it'll identify the name. Basically, it'll act as a roadmap in terms of what Oracle is looking for. Additionally, I like to start off in terms of discussing the log files. With Access, you're just basically going in, making your changes, making your edits. With Oracle, it gives you the opportunity essentially to log everything that you do. So it will give you the chance to log all of the modifications that have been made to the database. This is important when you look at larger enterprise applications in terms of how they're existing in regulated or government environments, where it's key to really understand any changes that have been made. So when I talk about log files, what I really am talking about is that primary ability to record all changes made to data. So for redo log files, the primary function of a redo log is to record all changes made to data. I've read it twice, so I think you guys know what that means related to the quiz. An item that you really need to remember as well too is that every Oracle database has a control file, and the data files contain all the database data. Moving on to the next slide. When we get into archive log files, I want to talk with you a little bit about the overall concept of archiving. As I mentioned in previous classes, some of the databases that my team currently supports have hundreds and hundreds of thousands of records that go back for a long set period. And when our customers are running reports, most of the information that they're looking for goes back only a certain period. But a number of those federal agencies and pharmaceutical customers are required to store data for 7 years or more. If you turn on the archive log mode within Oracle, essentially what it will do is allow you to automatically log files. So from that perspective, it is going to take those files that you're tracking with, all those logs, and archive them for future use. Next, let's talk about parameter files. Parameter files are one of the key files within Oracle. The reason for that is it contains all of the configuration parameters that you're going to have for both the instance and the database. And I haven't mentioned instance but more than once related to class. I'm sorry, related to the overall customers that we support. When I'm looking at instances versus databases, if I were to take the Oracle software and install Oracle, I would have essentially one instance of Oracle. I can then carve out additional instances off of the same hardware that will essentially act as unique solutions for customers while still leveraging the same hardware platform and basic code. In terms of additional log files, two of the ones that pop up most often in database development are alert and trace log files. Essentially, this allows database developers to determine where errors are. It's essentially a troubleshooting guide if queries have been written, if reports are being run that aren't running properly. The alert and trace log files will allow you to essentially see where it is, as well as put in a chronological log of messages and errors to help the database developer to ensure that it's easier to find the problem, troubleshoot the problem, and map it back to what change was made in the solution. When we were talking in class on Thursday, I went through a scenario in terms of a conceptual design to a physical design, in terms of going from a 10,000 foot view to a 5,000 foot view to a 1,000 foot view. From a logical structure perspective within Oracle, you essentially have the same general concept. So at a 10,000 foot view, you have an instance. At a 5,000 foot view, you get into the concept of table spaces. Now, a database is divided into logical storage and then breaks down from there. So at the higher level, you're going to get into a table space within the instance. The next level down from a granularity perspective is going to be Oracle data blocks. So Oracle data blocks make up a table space. So just think of it in terms of having a larger area and then just a subsection within that area. The subsection is the data block. The table space is the entire block. Now, when you get to the next level, you're going to see extents. Now, extents really maps out the specific number of data blocks used for a specific type of information. What that essentially means is you're able to map data blocks of storage within an instance to tie it back to a certain application, to a certain job, to a certain script, and allow you to more granularly map it out. When you look then above extents from the next level, you're looking at segments. So a segment is essentially a set of extents. So you've got table spaces, and extents are a block of table spaces. Segments are a block of extents. There are four different types of segments. The data segment, which stores table data, the index segment, which stores index data, and the temporary segment, which is essentially a temporary space used during execution. What that means is when commands are being run, that space is created in order for the SQL to be run against the system, as well as then a rollback segment. Rollback stores all of the undo. If you look at it from a Microsoft Word perspective or other applications, you're able to go in and essentially redo or remove a change that has been made. From an Oracle perspective, all of that information is based out of the rollback segment, which stores any of the undo information that you're storing. So visually, you can see segment, extent, data block. So hopefully this allows you to essentially see the different granularity of the sites. I mentioned on several occasions the concept of schema. In an Oracle perspective, schema is viewed essentially as the overall collection of database objects. So I'll use the IRS Learning Management System as an example here. So the official definition for schema shows that it's essentially owned by a database user. When I'm setting up a schema within IRS, there's a specific schema related to the plateau files, which is their learning management system, on that Oracle database. There's other schemas running on the Oracle database, but one specifically to the application. That essentially means that those objects map back to the specific data within the site. So the schema for Plateau is essentially containing all of the database data related to learning, related training, job history. It maps out all of the tables, all of the views, essentially shows within this overall global instance of Oracle for the IRS that this schema is specifically just geared towards this one application. Just for a little bit of humor here, the a lot of times when you get into truly understanding databases, it can get complicated, and a lot of people don't truly understand the intricacies of what Oracle needs in terms of being able to configure, in terms of being able to customize, and you have essentially some bad design that comes out from those who are doing the highest level of design. It's one of the reasons why I take it to the highest level. So I've mentioned a couple of times the concept of a database and then an instance. As I mentioned in a previous class, I had the opportunity to actually install Oracle in Helsinki, Finland for Nokia. And in that situation, essentially, what I did was I took the software and I ran the install. And that essentially created for me an Oracle database. What I then needed to do is create an instance within that database specific for the application that was being run. Every time the application is run for that instance, it's going to um, enable and allocate a global area where all the processes are going to run, where all of the memory is going to be stored, and the combination of those processes and the memory that's stored is called that Oracle instance. Carving it down from a global area perspective, we're getting more physically into the concept of memory. So if you think of it in terms of a storage component, this is where within the database, the the memory the memory region basically contains all the data and control information for that instance. So if I'm going in to the instance for the IRS, the system global area is basically going to be the roadmap to control that portion of the database for the IRS. That then breaks down into additional levels. So when I'm looking at the system global area, the first key idea there that you're going to be looking at is the overall database buffer cache. In the buffer cache, think of it how when you're online, your web history is showing and you're caching certain information for future use. Databases have the same general concept related to how those recent actions and recently used information is easily accessible. So when you're looking at database buffers store the information, and then a set of those buffers is called a database buffer cache. So as you're seeing this from a definition perspective, we're basically continuing to go from smaller to larger, both from a physical perspective as well as from a memory perspective. Continuing on this concept from a high level definition perspective is the concept of redo logs. So when you're getting that redo log buffer, it's really where you're storing all of the redo entries and the log of changes made to the database. Our database engineers spend a significant amount of time looking at those log files when there's a problem. And it allows you to see date, time, when the problem occurred, and mapping it back to the system. Every system, every site needs what I would tend to call a playground. And in that perspective, that playground is where a lot of the different elements of the database need to meet. Within Oracle, you will see that referred to as a shared pool. So, from that perspective, it's really where you're taking code from different pieces of the application and accessing it in a memory perspective to show which areas are requiring the most memory. I'm going to come back to program global area, but I wanted to see this from a diagram perspective. As we get deeper into the semester, you'll really understand what's part of that, what Java pool really is from a system global area, what I mean when I say redo buffer. But right now, I'd like to continue and talk a little bit more about background processes. Background processes run constantly. When you start up Oracle, there's a number of them that are going to essentially work um, on doing such items as backups, doing such items that map out the memory structures. When I look at a common background process, the system monitor is key. This is going to show database engineers how the system is running in terms of where um, items can be cleaned up or optimized, or what happens to certain files after database crashes. If you think of it from this perspective, we've all had to turn off our laptop earlier than we'd like to, and had files brought back when we rebooted that were recovered files. The system monitor allows us to see where some of these problems are, or um, um, some of these restored files are, and allow us to see whether or not we want to continue those, if we need to allocate more space for those. It basically acts as, for lack of a better expression, a cleaner. Process monitors and database writers we're going to come back to, but from a database writer perspective, what I'm really looking at is how the blocks are being written. Log writer and archiver we'll come back to. Several of these we're going to come back to over the course of this class. From that perspective now, essentially what we're looking at is the end of the first part of this lecture. Additional files are being posted, and we'll be coming back to this lecture shortly in a separate video file. Thank you.